In this segment, we will continue our discussion on finding elastic moduli of unidirectional lamina. We'll concentrate on nu12 here. We have already you already looked at the video lectures for E1 and E2. Let's go and see how we can find the Poisson's ratio in E12. We are not going to go to the derivation for this one because it's very similar to what is being done for other derivations. But you can look at the textbook and be able to follow it yourself. Main thing is that you are applying strain in direction 1. So you're applying the strain epsilon c, let's suppose, in direction 1. This is direction 1. And then what you're trying to do is you're trying to figure out, hey, what the strain is in direction 2. Normal strain is in direction 2. What are the changes in the thickness? What are the changes in the length of this particular composite material here? And based on that, you'll be able to develop the relationship between the Poisson's ratios for the fiber matrix and the corresponding fiber volume fractions. So this is what you end up with. You end up with, again, a rule of mixtures formula where the major Poisson's ratio is given as the Poisson's ratio of the fiber times the volume fraction of the fiber plus the Poisson's ratio of the matrix times the volume fraction of the matrix. So we're going to straight away jump into an example. So here we are asked to find the major as well as the minor Poisson's ratio of glass epoxy with 70% fiber volume fraction. So if that is the case, we get the Poisson's ratio for the fiber and the matrix from tables 2.1 and table 3.1 and 3.2. This is our rule of mixtures formula for the Poisson's ratio. So we have 0.2 and 0.3 as the Poisson's ratio of the fiber and the matrix. We have 70% fiber volume fraction, and of course that means 30% volume fraction of the matrix, and that gives us a Poisson ratio of 0.23. Again, you will find out that the Poisson's ratio, major Poisson ratio which you're going to get based on this formula will be somewhere between the Poisson's ratio of the fiber and the matrix itself. If we want to find out the minor Poisson's ratio, then we already know that we know the reciprocal formula, right? Nu21 by E2, and that gives us nu21 to be equal to this. We just found out the major Poisson's ratio to be 0.23. E2 is this much and E1 is this much. E2 we found out from the formula, reciprocal formula of this one. If you want to review the formula which we used to calculate the transverse Young's modulus, 10.37, that came from this relationship right here, and that gives us a nu21 of 0.03941. And that's the end of this segment.